Hi, Sam here from Roberts Geospatial. Today I want to show you the processing menu in ProRaster Scientific. So click this button, drop the menu down, and you'll get the processing operations that are available to you in the current version. So the difference with ProRaster Scientific Processing is that in most cases we don't produce a new physical raster from the processing operation. We produce a new virtual raster from the processing operation. So that means that the processing operation actually takes no time to execute. It just writes out a new virtual raster, and then it will immediately open that virtual raster in ProRaster Scientific, and you'll be able to visualize it. And then as you render the raster, the actual processing operation will be being executed in real time on the data at the resolution at which you're visualizing the data. So in ProRaster Scientific, that might be all you want to do. You might be happy with a virtual raster output and then to reuse that virtual raster in ProRaster Scientific. Alternatively, you can then run an export operation and take your virtual raster and crystallize it into a physical raster on disk. So let's take a look at that to start off with. So firstly, you can see that there's export operation and export operation batch, and most of these processing operations have a batch mode where you can run the operation on multiple input files in sequence and get multiple outputs from those input files. So let's do export operation. So firstly, we define our input raster, so you can browse for a raster, or you can select an existing raster source if you have one created. So let's browse for a raster. I'll go into I'll go into users, my username. Sorry to waste your time with browsing, but we'll get a multispectral data set. I'll take this scene sequence. So this is some Landsat data in a scene sequence. So we've got our input. Now we go export the source raster either to an MRR file, or we can export the source raster to a folder in one of these formats, GeoTIFF or band interleaved. So let's just output to an MRR first. So let's set the output file name, temp, save, and then we can filter it. So firstly, you can export all events, or you can just export the last event, and you can export all fields and bands or export selected fields and bands. We're going to export all, and you can set this resolution level. So at resolution level 0, you're targeting the base resolution. For Landsat, that's 30 meters, but for the purposes of demonstration, I'm going to go up the pyramid so we have a much smaller output raster. So it comes up with this processing dialog and chugs through. And if we bring up File Explorer, once this is done, so that's done. Here's the MRR format raster that it produced, and you can see that we've got all of our fields and bands from the original scene sequence data, and we also have all of our events, so we can flip through these events in the MRR, and that's all being crystallized into a raster, and here it is, 120 odd megabytes. Of course, that's at a resolution much lower than the base resolution. So that's exporting to an MRR. MRRs are only really useful in ProRaster Scientific. You can also load them into MapInfo. Let's try that again, and this time we're going to export to TIFF files. So sorry, I have to browse again. RGE, ProRaster, MSS, Tritchar. Go back to that scene sequence MVR. Now I'm going to export to a folder, and I have to select that folder. So let's come down to D, temp, and I'll make a new folder. And if I just paste, it's actually copied the file name that I selected as the input onto the clipboard, so you can just paste in that file name and select that folder. So that's my output folder in TIFF format. We're going to go right up the resolution level again. We'll do all fields and all bands. So what it's going to do now is it will output a TIFF file for every band and for every field and for every event, temporal event that's in that raster, which is going to be quite a number of TIFF files. Much more messy than just outputting to a single MRR file, which is able to contain all of those things. But if you want to take data into some other system, then it needs to be transportable, and this is the most transportable way of doing it, outputting everything into single banded TIFF files. So let's go to the D drive here and see what's happening. So it's going into scene sequence A, that's the folder that we created, and here you can see folders appearing for each field that it's created. So QA just appeared. So if we go into this field, you can now see there's an event for every event in the raster, and then go to details here, and then within each event we have a TIFF file for every band in that field in that event. So at the end of the day, getting more QA data, we'll get the mask data next, I think, and that will be about it. Notice that the progress bar is a little bit wonky. We'll fix that one day. So we should be just about there, I would say. Here's all the masks being written out for all the different events. So we're all done. So there is a huge collection of TIFF files output from that one virtual raster file. And of course you can go into one of these, click on something, red band, drag it into ProRaster, and there it is. At a lower resolution, of course, because we output it at resolution level 4. Okay, so that's exporting. We can also do statistics analysis. This is another one which will actually do some computation. So if I browse for a raster, and okay, once again we're going to go back to our spectral raster. I'm going to browse. Sorry, I'm so slow on the mouse. Scene sequence. And here's my output raster output file name. So in this case, we're outputting statistics. Let's put that into that temp directory. So let's look at so digital numbers. Compute for each individual event, resolution level, say 3. Hit OK. Now it's computing statistics. And if we go into that directory again, so it's output a CSV file and an STTX file and a text file. So the text file is your report, which has got all your statistics data in it. Your CSV file, contains statistics for each one of the events that were in that raster, if there are multiple events. And then the STTX file is binary statistics, which are used by ProRaster. You won't use those directly. Okay, so that's statistics. What else do we have? Join operation. So join is going to take multiple rasters and put them together into one raster. So it's like a merge operation. And you can see the only option here is to select a raster source. So let's create a raster source. Here's my raster source editor. I'm going to add a raster source. We'll call this TIFF collection. Go down to dtemp, and I've got some just a few TIFF files here. So let's select those TIFF files and drag and drop them onto the raster source editor. And just preview them. So these are actually terrain rasters. So hit OK. Now so let's see what we get if we create a new algorithm for raster source. So I'll take that TIFF collection. So you can see I've got 4 TIFF files here. And if I render them this way, they all get rendered individually, which doesn't look very good. But if I join them together into a single virtual raster, so now I'll choose that TIFF collection as the raster source. Set my output file name to, so we'll call this combined. Save. Hit OK. And then that joined virtual raster is immediately opened in ProRaster Scientific, and you can see that the coloration now across those 4 individual TIFFs is all the same. So that's a join operation. So clip to Polygon and clip to Polygon batch. So if I was to display, for example, say merit. So there's a global DEM of the world. It's at 90 meter resolution, so you can zoom right in. So let's clip this. So let's go processing, clip to Polygon. I'll use that raster source because I've got it right there. Set my output file name. That's okay. Then select a polygon. So have one here, Hawaii. Okay, well, so we're going to clip to Hawaii. Hit OK. And now that global scale raster has been clipped just to Hawaii and its islands. So that's clipping to raster. We can also do, that's clipping to Polygon. We can also do a clip to raster. And that requires, so this is a raster masking operation, which we've seen with our spectral data, and that requires you to create a raster mask. So let's try creating a raster mask first. What am I going to create a raster mask from? Okay, so let's create a raster source. I'm going to add in world cover. And go to my data directory, world cover, here's my MRR file, drag that in. So this is a classified raster of the whole world at 30 meter resolution. Hit OK. So let's go create raster mask. I'm going to use world cover. I'm just going to use the index for the classification index. Specify my output file name, so this will be, I'm going to call this cropland. So where the world cover index is equal to 3, that's the classification for cropland. So let's take that index, A00 equals 3. Actually, I think it's just equals 3. In that case, we'll output a value of 1, otherwise we'll output a value of 0. So this is just a if then else. So if we have cropland, we'll output a value of 1, otherwise we'll output a value of invalid, null, and that's going to be our mask. Hit OK. Gives us a preview of that raster, so you can see here's India, for example, most of it's cropland. Okay, so now let's try doing a clip to raster. Let me get rid of some of these things. So let's do a clip to raster. We also have a batch option on this one. So we'll put in our, we'll clip, say, merit. So we'll take our DTM for the world, and this will be cropland DTM. And then we'll choose our raster mask, which will be the one that we just created, cropland.mvr. Raster mask, field and band, hit OK. So now we've clipped the DTM raster to only those areas that are cropland in the world cover raster dataset. So we can zoom right in, and this thing is at 1 arc-second resolution. You can see that all these grey areas where it's been clipped out, and these other areas showing our terrain are areas that are under cropland according to that classified raster. So that's clipping by raster. Let's just take a look at Reproject. So I have Reproject, Resample and Realign. These all use the same dialog. They're a very similar operation, and you can do a batch operation. So what are we going to look at? Let's say we've got Jebco. Let's put that in. Okay, so this is a global DTM in a latitude-longitude coordinate system. So let's reproject this. So reproject, hit reproject, load up Jebco. It tells me that my current coordinate system is lat long, and so we'll go in and select a new coordinate system. So we'll go to projections of the world. Robinson perhaps, or mile wide, or Gall, Miller, Robinson. Let's try Robinson. So then I need to set my, I can set my cell size and my origin. These are kind of optional, and probably there's a whole new video in explaining what you should set your cell size and your origin to. In virtual rasters, it's very different to physical rasters. The cell size and the origin are not so important. In fact, this origin, doesn't matter what you set it to, you won't move the raster more than half a grid cell. And also the cell size kind of depends on it. All it does is affect the number of levels of resolution in the raster. So let's just hit OK and go with what it comes up with. So there we have that raster reprojected to Robinson projection. Next we have the calculator. So this is a raster calculator operation. So let's do something here. We'll go into Denmark. So I have some 2 Denmark rasters here. These are huge rasters. In fact, before we do the operation, let's just take a look at these rasters and I'll show you what they look like. Get rid of that. Denmark. So digital terrain model, DTM. This is a DTM for Denmark. It is at 40 centimeter resolution. So it's derived from LiDAR data. And as you zoom right in, you can see the furrows in the fields. So very high resolution, and it's a huge raster, something like a trillion cell raster. So if you do the maths, if you have a trillion cells at floating point storage, that's 4 bytes per cell, that's a 4 terabyte raster. But you can see that the raster here is only 170 gigabytes, and that's because MRRs are using compression. But if I was to process this raster, I would have to write out 4 terabytes of data and compress it all. It takes a very long time. Not just hours. It can take days to process these sorts of rasters. But you can use virtual rasters to do processing instantaneously. So if I go into this raster, so we'll load up, going into Denmark. So we have a digital terrain model, which is the ground surface, and we have a digital surface model, which is the first return from the LiDAR. So that'll be the tops of the trees and the tops of the buildings and so forth. So let's put in the DTM. I select the field and the band, or all fields and all bands. I just want the RL. That's the only one that's in there anyway. And the DSM. So I now have two variables that I can draw from for my raster calculator expression. So I'll specify my output data. So this is going to be difference. And then my expression, so I'm just going to go DSM minus DTM, so that's B naught naught minus A naught naught. Hit OK. And immediately it's produced a result. So I'm just going to let's go in and just change a few things. We'll turn off this and we'll bring the scale down. And I don't want equal error, just have a linear transform with a manual clip, say about 30 meters high, and just knock that down a bit. So if we come in here, well, here's a city, and we'll get some cell value going here. So you can see that everything's 0, where the ground is the highest surface, and then we have our shrubbery and our trees and our buildings. This building's 34 meters high, and you can see that with very high resolution, we're really even picking out fence posts and so forth. And we're doing all this on a 1 trillion cell raster in real time. If I wanted to turn that into a real crystallized raster now, I run an export operation on this virtual raster and go away for 2 days and come back when it's finished. So here's all the trees. So that's the raster calculator. Conditioning, I perhaps won't demonstrate conditioning. So conditioning allows you to apply a data conditioning object to a raster, and you select one from ones that you've defined with your data conditioning editor. I don't have any at the moment, but you go into your data conditioning editor, create a data conditioning object which will remove bad values out of the raster, might do transformation, might cap values to a certain range and so forth, and then you can apply that via this conditioning operator. And then the next one is image sequence. I won't demonstrate this one either, but this allows you to take a set of rendering algorithms, which are MRD files, each of which is at a different, say, time, and put them together into a sequence which you can you can then just flip through in another rendering algorithm. So so for example, if you were doing multispectral analysis and you had Landsat data as well as Sentinel data over a particular target, well, at the present time you can't mix those data types in one of our products, in one of our multispectral products. So you'd have to create your products separately, but then you can create rendering algorithms for each one of those and then put them together using this image sequence processing operation, just to put the whole thing together into one sequence. So that's what that does. And finally on here, you can output the current algorithm that's being displayed to MapInfo Pro. So that only works if MapInfo Pro supports the features in the algorithm and the features that are in the virtual rasters, and unfortunately it only supports very early versions of those things. So the vast majority of virtual rasters and rendering algorithms that you can produce in ProRaster Scientific will not be supported in MapInfo Pro. So a lot of the times when you run this, it will just say it's failed to open, and but it's there for completeness because that's one of the features from ProRaster Essential and ProRaster Premium. So that's the processing menu in ProRaster Scientific. Thanks for watching.